Well, hello, my friends. This is Rusty Waller with the Teaching and Learning Center at the American University of Ross, Alabama. In this video, we're going to examine conditional probability and continue our examination to review a specific example. If you will recall, conditional probability is the condition that one thing happens based on the prior occurrence of another thing. For example, what is the probability that the second roll of a six-sided dice will be 3 when the first roll of the six-sided dice is 4? Now, in reading this problem, there's one thing taken for granted. That is that the dice are fair and unbiased. This will be a very important concept as we continue this course and move into statistics. The idea is that the outcome is fair, that each outcome has the same probability of being predicted. So what is the probability that if we roll a 4 on the first dice, that in our second roll of the six-sided dice, we get 3? And another way of writing that is, what is the probability of A given B when A is an outcome of 3, B is an outcome of 4? You will recall that the probability of A given B implies that B happens first and then A happens. What is the probability that an outcome of 3 will happen after we get an outcome of 4? Well, let's start with this. And as all things, it's important to draw a picture. Pictures relate all of the possible outcomes. Here in this grid, we have the first roll of the dice being 1 through 6, the second roll of the dice being 1 through 6, and each one of these dots represents the throw of the two dice. For example, if we randomly select one of these, that dot has a first roll of 4 and a second roll of 4. If we select another dot, that dot has a first roll of 6 and a second roll of 3. So here's the third one. We select this dot. Its first roll is 1 and its second roll is 6. So, we've got this kind of lined out. This picture illustrates all possible rolls of the dice. Now, the probability of B, where B is 4 on the first roll, might be represented by this picture. Here are the possibilities where we get a 4 on the first roll. You will notice that there are 6 possible events that satisfy this out of a total of 36 possible events. Here's a 3 on the second roll. You will notice that the probability of getting a 3 on the second roll might well be given as any one of these 6 events, but to throw a 4 on the first roll and then a 3 on the second roll would be represented by this particular dot. Let's go back. The probability of B, where B is equal to 6 events. That's the number in B. Okay, and the probability of A union B is equal to 1 event, or A intersect B is equal to 1 event right here. So in this particular dot, we got a 4 on the first roll and a 3 on the second roll. Now look at that again. B has possible 6 events. A intersect B has 1 event. So in our formula where the number in A intersect B divided by the number in B, we get 1 over 6, or we get 0.1667 or 16.67%. I will remind you that for some reason, statisticians just love 4 decimal places. I don't know why it is, but we will humor them on that. That's because certainly that most of the tables are in 4 decimal places. But why is that? I don't know. We'll just go with it. We'll be happy with it. Now, here's another way of calculating that. Not just the number in A intersect B divided by the number in B, the probability of A intersect B divided by the probability of B. The probability of B is 6 possibilities out of 36 events. And the probability of A intersect B is 1 possibility out of 36 events. So the probability of A intersect B divided by the probability B is 1 over 36 divided by 6 over 36, or again 0.1667 or 16.67%. I want you to observe that it didn't matter which formula we used. The formulas gave us the same thing. They were just different ways of getting to the same place. Again, I want to thank you very much for your support. I hope that this video has proven helpful, that you're beginning to get a picture of conditional probability. And in closing, I'll once again give you the mantra of the Hunger Games. May the odds be ever in your favor. Of course, unless you and I are in the same event. Then it's every man for himself. You have a good day.